Alright, so today we're going to start our first lesson in geometry. We're going to do section 1.1 and 1.2, okay? The first thing I want to mention is in geometry we have defined terms, which of course have a formal definition, and then we have what we call undefined terms, and these would be terms that do not have a distinct definition to describe them. In other words, they use words to describe what they look like and things like that, but they do not have a formal definition. The first one would be point. Okay, and this is what a point looks like. It is a dot. It is represented by a capital letter. The next one is a line. Notice it goes on forever in both directions. It's got 2 points on it. And to name that line, we also have a lowercase cursive letter by there. Okay. The last one is what we call a plane. It looks like a square or a rectangle or some sort of quadrilateral. Notice it has 3 points in that plane. It also has a capital letter cursive at one of the corners to also name that plane. Alright? The next thing I want to talk about is collinear points and coplanar points. Okay? Collinear points would be points that are on the same line. Points that are on the same line. Coplanar points now would be points that are on the same plane, okay, and I highlight those to give you a little idea to remember those by, okay? All right, so the next thing we want to look at is our first example right here. It says, use in this first example, use this figure to name, answer these questions over here. So A says, use the figure to name a line containing point K. All right, so right here you've got point K. Notice it's in this plane. It's also on this line. If I were to name this line, I could call it line A, okay? I could also use any 2 points on that line to name it. And then notice the symbol for that, above the letters to name it, would have to be this line symbol. So I could say JL, I could say line LJ, I could say KL, JK. Any 2 points on that line A would name that line that contains point K. B says, use the figure to name a plane containing point L. Obviously, there's only one plane here. I could call this plane B, because remember, we've got that capital cursive letter over here. I also could use any 3 non-collinear points to name that plane. So I could call it plane JLM if I want to, and the order of that does not matter, as long as there are 3 points that are not on the same plane. The last one says, name 4 points that are coplanar. So 4 points that are on the same plane would obviously be J, K, L, and M. All right? So that's a section of things that you're going to do on your homework today. All right, the next thing is asking us to describe which geometric term is modeled by each object. So a button on a table would obviously be describing a point. The ceiling in your classroom, if we look at the tiles, then each tile would represent a plane. All right, let's move on. So the next page, if I go ahead and start with example 3, you're going to have something that you're going to have to draw. It says, draw and label a figure for the following situation. Plane R contains line A, B, and DE, which intersect at point P. All right, so if I go ahead and draw my plane, okay, there's different ways that you could draw this. I'm going to go ahead and put R in the corner because it's calling it plane R. These 2 lines are in the plane and they intersect at point P. Okay, so here's a line here. I'm going to call this, they've got points A and B on it so that it's named line AB. And then DE, and they intersect together at one point called P. This other line right here has the points D and E on it. And then it says add point C on the plane R so that it is not collinear, so it's not on both of either one of these lines. But it is in the plane. So I'm going to go ahead and just add point C somewhere outside of the 2 lines, but still in the plane. All right? Okay, so let's move on. Example 4, here we've got, and I'm going to keep this expanded a little bit bigger. I'm going to go ahead and read off the notes of what it says, but I want you to see this figure that we have over here. in this figure, notice we have this plane T. We've got this line AZ that's intersecting the plane. We've got this line BN that's also intersecting the plane. We have this line XR that's in the plane. And then we have this line AB that is outside the plane. A is asking us how many planes appear in this figure. Well, obviously, you know that you've got one plane here, okay? You also have to remember that any 2 points that are not on the same line that exist will also be considered to form a plane as well. So if we've got A and B, and if I pick another point not in that same plane, R, or A, B, and O, that would also be considered a plane. So there are actually 2 planes that appear in this figure. Okay, the next one says, name 3 points that are collinear. So again, collinear means that they are on the same line. So that would be what? X, O, and R could be an example. And I guess that will be our only example for this question. C says, are points X, O, and R coplanar? And that would be yes, because they're all in plane T. Okay? The last question is asking us, at what point do BN, here's line BN, and XO intersect? So, of course, they intersect at point R. Okay? And 2 lines will always intersect at a point. All right? Let me move on here. Moving on to section 1.2. Here we're going to start talking about the betweenness of points, okay? So if you look at this model here, it says that by this definition, point M is between points P and Q. And if that is true, then this part of this segment of this line plus this part of this segment is going to be equal to the entire length of the whole segment. If M is between P and Q, then P plus PM plus the measure of MQ is going to be equal to the length of PQ. Okay? One way I like to say this is part plus part equals whole. Okay? Moving on to the last little bit of the section here. It says, in this first example, it says, find BD, assume that the figure is not drawn to scale. So again, notice you've got your segment here. C would be between B and D. So if I were to write this as my given theorem a while ago, BC plus CD would be equal to the whole thing, which is BD. Again, you could use your part plus part equals whole. Okay? So whenever I plug in my numbers, I have, is that 16.8? Yes. 16.8 plus 50.4 is going to be equal to BD. And BD is what we're looking for. So again, if I were to add that, that would give me 67.2 millimeters is equal to BD. Okay? And then last example, and I will be finished. Example 6 says, find the value of X if ST and ST, if T is between S and U. Okay, so ST is 7X, SU is 45, and TU is 5X minus 3. So if I were to go ahead and draw this, okay, T is between S and U. And I want you to get in the habit of drawing things out, especially when it describes it, okay? ST is 7X. All right. TU is 5X minus 3. And then, of course, it says the whole thing, SU, over there it says it's 45. So this whole thing is 45. So now that I've got it set up, I can easily see how to set it up algebraically. Remember, we've got part plus part equals whole, or ST plus TU equals SU. All right? So when I add that up, I've got 7X plus 5X minus 3 is equal to 45. All right? So then I get 12X minus 3 equals 45. When I add 3 over, I get 12X is equal to 48 divided by 12, and I get X is equal to 4. All right, and it asks us to find X and ST. So again, then an ST would be 7 times 4, which would give us 28. there's ST, and then there is X.